Ever wondered why understanding relationship types in database systems is crucial? Well, let's delve into it. In the realm of database systems, relationship types are the glue that binds different entity types. They define the associations and interactions between these entities, shaping the very structure and behavior of the database schema. It's like drawing a map of a city, but instead of roads and buildings, we're charting connections and dependencies between entities. Whether it's a one-to-one association between a person and their passport, or a many-to-many relationship between students and courses, relationship types help us model these connections with precision. And why is that important? Because when we're designing a database, we want it to mirror real-world interactions as closely as possible. Understanding relationship types is key to designing a database that accurately represents the real-world interactions among various entities. Starting with the simplest, the one-to-one relationship. Picture this. You're in an airport, about to embark on a new journey. You reach into your bag, pull out your passport, and hand it over to the customs officer. Now, consider the relationship between you, as a person, and your passport. It's a perfect example of a one-to-one relationship in the world of database systems. Each person has exactly one passport, and each passport is uniquely associated with one person. There isn't a scenario where your passport could be linked to someone else, nor could you hold multiple passports. This is the essence of a one-to-one relationship. It's a relationship where each entity instance in one entity type is associated with exactly one entity instance in another entity type, and vice versa. So in a one-to-one relationship, each entity instance in one entity type is associated with exactly one entity instance in another entity type, and vice versa. Moving on to one-to-many and many-to-one relationships. One-to-many or 1N relationships are quite common in database systems. This type of relationship occurs when each instance of one entity type can be associated with one or more instances of another entity type, but each instance in the second entity type is associated with only one instance in the first entity type. It's a bit like a department and its employees. Each department can have several employees, but each employee belongs to a single department. This relationship mirrors real-world scenarios where hierarchical relationships exist. Now, let's flip this around and look at many-to-one relationships. In a many-to-one or N1 relationship, we have a situation where many instances of one entity type can be associated with a single instance of another entity type. This is essentially the inverse of a one-to-many relationship. Think about the relationship between employees and a manager. Several employees report to one manager, right? That's a classic example of a many-to-one relationship. It's a structure that's prevalent in organizations, where multiple individuals often report to a single supervisor. But what happens when we need to model relationships where an entity instance can be related to multiple instances, and those instances can also be related to multiple instances of the first entity type? That's where our next types of relationships come in, which we'll delve into in our next scene. Remember, understanding these relationships is all about recognizing the associations and interactions that exist between different entity types in the real world. By accurately representing these relationships in our database, we can ensure that our data is structured logically and efficiently, reflecting true scenarios and facilitating accurate data retrieval. These types of relationships are essentially the inverse of each other. Next on our list is the many-to-many relationship. Now this is where things get a bit more complex, but hang in there, it's not as daunting as it might sound. In a many-to-many relationship, each entity instance in one entity type can be associated with one or more entity instances in another entity type, and vice versa. Let's illustrate this with a classic example: students and courses. In this scenario, each student can enroll in multiple courses, and each course can have multiple students. It's a mutual two-way street of relationships, creating a web of interconnected entities. This type of relationship is crucial in representing complex real-world interactions in our database schema. So remember, when you hear many-to-many relationship, think of a bustling university with students starting between different courses, and each course filled with a diverse group of students. And that's the beauty of it. In a many-to-many relationship, each entity instance in one entity type can be associated with one or more entity instances in another entity type, and vice versa. Ever heard of a recursive relationship? It's a bit like looking into two mirrors facing each other, creating an infinite loop of reflections. In database terms, A recursive relationship is where an entity type is related to itself. It's like a social media platform where a user can follow other users, including themselves. Let's dive into a classic business example. Imagine a company where an employee can also be a manager. In this situation, the employee entity has a relationship with itself since a manager is also an employee. This sort of relationship where an entity is associated with itself is what we call a recursive relationship. This is a crucial concept in database design, especially for complex hierarchical structures like organizational charts, where an entity can have a relationship with itself at different levels. So, to recap, a recursive relationship is where an entity type is related to itself. Last but not least, let's explore the associative entity. In our journey through the database landscape, we've discovered different types of relationships that help us understand how entities interact with each other. But what happens when we encounter a many-to-many relationship? This is where the associative entity comes into play. An associative entity, sometimes referred to as a junction entity or a linking table, is a special type of entity that helps us handle these complex many-to-many relationships. It's like a bridge that connects two entities, allowing them to interact with each other in more than one way. To illustrate this, let's consider a classic example. Students enrolling in courses. In this case, each student can enroll in multiple courses, and each course can accommodate multiple students. This is a classic many-to-many relationship. If we tried to represent this in a database without an associative entity, we'd quickly run into problems. Enter the associative entity. In our example, we might create an enrollment entity. This enrollment entity serves as a bridge between the student and course entities. It doesn't just link them together though. It also contains additional attributes that describe the relationship between the two entities. For instance, the enrollment entity may contain attributes such as the enrollment date or the grade the student received in the course. So the associative entity does two things. It allows us to represent a many-to-many relationship in our database, and it gives us a place to store information about that relationship. It's a powerful tool that can help us create more accurate, flexible, and efficient database designs. An associative entity represents a many-to-many relationship and contains attributes that describe the association between the related entities. So to sum it all up, we've taken a deep dive into the world of relationship types in database systems, uncovering how they define the associations and interactions between different entities. It's been quite the journey, hasn't it? We started off with the one-to-one relationship, where each instance in one entity type is associated with exactly one instance in another entity type, just like one person having one passport. Then we moved on to the one-to-many and many-to-one relationships, where each entity instance in one type can be associated with one or more instances in another type, but each instance in the second entity type is associated with only one instance in the first entity type. It's the classic department and employee scenario. We also explored the many-to-many relationship, where each instance in one entity type can be associated with one or more instances in another entity type, and vice versa. Think of it as students enrolling in multiple courses, and each course having multiple students. We then dove into the concept of recursive relationships, where an entity type is related to itself. An employee can be a manager, and a manager is also an employee. And finally, we discussed the associative entity, also known as a junction entity or a linking table. It's used to represent a many-to-many relationship and contains attributes that describe the association between the related entities, like an enrollment entity that represents the relationship between students and courses. Understanding and correctly modeling these relationship types is not just about creating a database schema. It's about designing a schema that mirrors the real-world interactions and dependencies among various entities within an organization or application. It's about designing a system that works efficiently and effectively, a system that makes sense. By understanding these relationship types, you can design a database schema that accurately represents the real-world interactions and dependencies among various entities. Until next time, keep exploring.